Hello, and welcome to our virtual poster presentation of exploring the use of an experiential seismometer display to improve earthquake preparedness. My name is Megan Fairchild. You'll be hearing from my research partner Kane in just a moment. So I'm just going to briefly introduce the project. As you may know, Westminster College is situated along the Wasatch Fault, which is projected to have a magnitude 7 or larger earthquake in the next 50 years. So knowing this, we wanted to assess the current knowledge and preparedness of the Westminster community. And we also wanted to figure out if this TC1 seismometer display that we built was effective in facilitating learning about earthquakes and essentially helping to better prepare our campus community.
In our study, we used flyers, Facebook posts, and asked individuals to participate at random in the basement of Foster Hall. The first step in our data collection process was to administer a pretest survey, which measured perceptions regarding earthquake hazards and perceived levels of preparedness. After completing this survey, participants interacted with the TC1 seismometer and signage, then completed a post-test survey, which was used to understand the effectiveness of our exhibit in changing perceptions about earthquakes. A handout was also distributed, which included steps for improving safety in the event of an earthquake. Finally, a second post-test was sent over email 2 weeks later to assess actual behavioral changes, which we measured based on the number of steps each person took to prepare for a potential earthquake.
So as we mentioned before, one of the parts of this project was to create informational signage to present to the participants while they were interacting with the seismometer display. So you can see the two signs that we created. We blew them up really big and printed them on large paper for the participants. On the left-hand side is some information about the Wasatch Fault itself, including the recurrence interval, which is about 1,300 years for this section of the fault, the length of the fault, as well as a little diagram that shows the motion of a normal fault, just to give the participants a sense of the actual structure that they're living on. There's also a section about seismic waves and how seismometers use them to detect earthquakes. We really wanted the participants to understand what the instrument in front of them was doing rather than just jump and create their own seismic waves. And then on the right poster, we have a little fact sheet. On this one, we wanted to include information specifically pertaining to the Salt Lake City hazards, so the projected loss of life, economic damage, structural damage, that sort of thing. There's also a little QR code that we created that links directly to the Utah Geological Survey earthquake preparedness website. So it has lots of tips on how to prepare for a hazard like the one that we are expecting.
We had a total of 6 participants in this study, 3 of whom completed the first 2 surveys and 3 who completed all of the surveys. We developed what appears to be a reliable measure of danger perception with a Cronbach's alpha score of 0.875. And from the data we collected after interacting with the exhibit, an earthquake along the Wasatch Fault was perceived to be more likely, more dangerous, and more severe. And this was the case immediately after interacting with the exhibit, as well as 2 weeks after interaction. Additionally, after interacting with the exhibit, all participants indicated that they had intentions to improve their safety in the event of an earthquake, and each of them did take one or more safety precautions, which included talking with friends, family, or significant others about an emergency preparedness plan, bolting bookshelves and other furniture to the wall to prevent injury from falling objects, or purchasing emergency items such as canned food and bottled water. So while we have few responses in this study, we did see a change in earthquake danger perception and safety behaviors, so we feel that our methods would be effective in future trials. Our data was limited by a small sample size, and we did suffer setbacks, including but not limited to the COVID-19 crisis. So we plan to increase participation in the future in the hopes that we will gather consistent and concrete results.
So, in conclusion, even though our data was very limited by our small sample size, we did still have some interesting results. We found that the intention of the participants to increase their safety behaviors after viewing the seismometer display and the accompanying signage was much higher. Um, However, they didn't actually go home and implement these safety behaviors to the same extent that they had intended to, though they each did take at least 1 to 2 additional steps to improve their earthquake preparedness. So, because our data was so limited, we hope to replicate this research in the future in order to continue to explore these relationships between experiential learning and safety and hazard preparedness, but also as a means to better prepare the Westminster community uh, in the event of the impending earthquake. Thank you so much for taking time out of your day during all of this craziness to come to our virtual poster presentation. We really appreciate your time and attention, and we hope that you are staying healthy.